My name is Alexis Kasorik, and today I'm talking about the Unit 3 syllabus talking about isotopes and atomic numbers and mass numbers. So first, atomic number is the number of protons of each atom of that element. The periodic table is arranged by increasing atomic number, and so this allows us to identify atoms. It also indicates the number of electrons since an atom is electrically neutral. So if you see in the picture, the top number is the atomic number, and that is how the periodic table is written. And then the atomic mass is the number in the bottom, which is talked about on the next slide. So mass number is the total number of protons and neutrons that make up the nucleus. And when you're writing a chemical symbol, you write the symbol of the element as shown as X in that picture, and then on the top is the mass number, which is the protons and neutrons added together, and then the atomic number is written in the bottom left, which is the atomic number, and the number of protons is the same thing. An isotope is atoms of the same element that have different masses due to a different number of neutrons. And most elements have more than one isotope. And then an example of a group of isotopes is hydrogen 1, hydrogen 2, and hydrogen 3. And that is shown at the picture on the right. So when you're designating isotopes, there are two different ways to do it. So the first one is the hyphen notation, and that is the mass number written with a hyphen added after the name of the element. So an example of that is uranium, and then you write the hyphen and you write the number, which would be the protons plus neutrons, and that is shown right there. And then it would be the same for any other element. And then the second way you can designate isotopes is called the nuclear symbol way, and that shows the composition of the nucleus. So the superscript indicates the mass number, the subscript determines atomic number, and then subtraction allows the number of neutrons to be determined. And as I said previously, protons and atomic number are the same thing. So if you look at this picture on the right, for uranium, the hyphen notation is at the top, as I typed in the example, and then the superscript, which is the top left, that is shown as the mass number, and then the subscript is the bottom left, and that is the atomic number, also known as the protons. A nuclide is a general term for a specific isotope of an element, and it's also a kind of atom or nucleus characterized by a specific number of protons and neutrons. So a sample problem of determining protons, electrons, and neutrons for an element. So this slide shows chlorine at the top. So to determine the number of protons, electrons, and neutrons, the protons is shown at the number 17 at the top because that is the atomic number. And then the number of electrons is the same as a proton since there is no charge to chlorine. And then to determine neutrons, it is the mass number minus the atomic number. And if you take 35 minus 17, you get 18 neutrons. And then for the bottom example, this one is showing you carbon. So if you're looking at the element on the periodic table, which would be the picture on the right, you determine protons and electrons by using the top atomic number. And then to determine your neutrons, you would take the mass minus the number of protons, which gives you 6. And as you see in the picture with the C, the 12, and the 6, the mass is at the top and the number of electrons is on the bottom. For ions, so ions are a charged atom due to the loss or gain of electrons. So cations are positive, which means you're losing electrons, and then anions are negative, which means you're gaining electrons. And the charge is written in the upper right corner of the symbol. So an example of magnesium, you have 2 plus because you are losing 2 electrons. And then for bromine, it is a 1 minus, which means you are gaining 1 electron. And when you have a 1 plus or minus, you don't write the number 1, you only write the negative sign. For determining number of electrons and also the complete chemical symbol, so the complete chemical symbol right here is also shown with the charge. And so for magnesium, which is the top example, you have the 24, which is your protons plus neutrons. And then the bottom number is your protons. And then you write the charge at the top, which is your protons plus or minus the number of electrons you have. So determining protons, neutrons, and electrons, you would take the bottom left number, which is the subscript, to find your protons, which is 12. Neutrons, you do the top subscript, or the superscript minus the subscript to get you 12 neutrons. And then for the electrons, you take the number of protons. And then for this one, since it's 2 plus, you're actually losing the electrons, so you would subtract 2, which gives you 10 electrons. And then for aluminum, it's the same thing. And once you do all the adding and subtracting, you end up getting 13 protons, 14 neutrons, and then you do 13 minus 3, which gives you 10 electrons, since it's 3 plus, but you would be losing the electrons. Now, relative atomic mass is a standard used by scientists to compare units of atomic mass in the carbon-12 atom, which has been assigned a mass of exactly 12 atomic mass units, and an abbreviation for that is 12 AMU. So the AMU just means atomic mass units. It's just an abbreviation. And then average atomic mass is the weighted average of the atomic masses of the naturally occurring isotopes of an element. And on the next slides, it shows you how to find the average atomic mass of isotopes. So the equation for this is AM equals AM times AB plus AM2 times AB2, and then you would keep repeating that if there are more isotopes, and then once you do that, you divide it all by 100. So AM obviously stands for atomic mass of the element because that is what you're finding. The AB stands for the abundance of the isotope, and then the 1 and 2 is just to separate your different isotopes, so you would group all the first ones together. And then AM1 and 2 is the atomic mass of the isotope. So if you're actually solving for an equation, so if you're given the isotope copper 63 and copper 65, the abundances of them is 69.15 and 30.85, and then the mass, you use the full number to get a more approximate or a more accurate answer. And those are shown as 62 and 64 with the decimals written out. So if you're given the equation at the bottom, try and solve the atomic mass of these two isotopes. So if you plug that in, if you plug all those numbers in, you should get 62.929601 times 69.15. Then you add that to 64.927794 times 30.85, and you divide that all by 100. And those numbers were all taken from up here. The 69 and the 62 is being multiplied together because they are both from the same isotope, and same goes for the second one, the 30% and the 64 are grouped together. And once you plug that into your calculator, you should get a final answer of 63.55, and your units is AMU, standing for average atomic mass. And that is the end.